Welcome back to another AP Pre-Calculus video. Today we'll be going over topic 3.12, worksheet A. Hopefully you already know but 3.12 is a whole bunch of memorizing equations. We have the Pythagorean identity and equivalent forms, sum and difference identities, and double angle identities, along with inverse trig identities too, but I don't think that one is as important as the other two. So I don't think you have to memorize the inverse trig identities, but that's there just for you to understand how the trig identities work, along with knowing the 6 trig, which are sine, cosine, tangent, and then we have the other 3, which is cosecant and secant and cotangent. So you need to know that cosecant goes with sine and secant goes with cosine. So you can memorize, like, it's the opposite letter, right? Like S plus and C, and then C and S, and then cotangent, you have the word tangent in it, so it's tangent. And you have to know that, like, sine, I'm not doing number 1 yet, I am explaining some stuff. So sine is equal to 1 over cosecant, because we know that cosecant goes with sine. The opposite would be 1 over cosecant, because it's the same thing with the other side. So if I try to find cosecant, a number, it would be 1 over sine. And then that same thing applies with cosine, but with the opposite, which is secant. And you can do the other way, 1 over cosine of x. And then for the tangent, we have, tangent is always the slope, right? So it's sine over cosine, but tangent of x can also equal just 1 over the opposite, which is cotangent, just like the other two, but tangent also equals that. So with that, we can also tell that cotangent can equal to cosine over x, because it's just the opposite, also equal to 1 over tangent of x. So that's the other thing you also have to memorize, along with the big formulas. Those are hard to memorize, so hopefully, and if you want, you can have those formulas with you while doing this assignment, but try to memorize it while you do it too. So let's start with question 1. So here we have g of x. Rewrite g of x as a fraction involving powers of sine of x and no other trig functions. So our answer should include only sine in it. So let's go ahead and get started. So we have tangent and secant here. I know that tangent can be changed into sine x over cosine x, and secant, it can be changed into 1 over cosine. So I think you want to think of the things that you can change it to. It'd be better if you can try to think of the thing you can change it that would include what you want to include, like sine, for example. So here, tangent, with this tangent, it includes sine, but secant, you can never just include sine. You can never have just sine. So the other way of writing secant is 1 over cosine. So yeah. So if we multiply that, it would be that. So 2 of that give me squared right here. And you don't put squared after the x, you have to put it in between. So based on the Pythagorean identity and equivalent form, the cosine squared, we know that the equation looks like this, right? So let me rewrite that. The equation looks like this. We want to, I see that term is in the equation right here, so I want to isolate this to see what it looks like. So I just subtract these two. Looks like cosine squared is equal to 1 minus sine squared, which, look, it has sine in it, so that actually looks good. So sine x over what equals to this, which is this right here. Make sure you're putting x and not theta, because in this problem it's x. So that is our answer. So moving on to the next problem. We want to rewrite this with tangent only. So, okay, looking at this one right here, I can see this one kind of goes with this equation that we wrote earlier, except it's 1 minus cosine. So if we go back to the original one here, so it's just sine squared theta. If we minus, and this is just 1, so ignore this right here, minus cosine squared. That would be 1 minus cosine squared. If we minus this on both sides, it would give us this on this side right here. And so this would equal to sine, because if we minus this, we isolated the sine. The top equals sine squared. Oh, I actually put theta there. It should be x. In the bottom, you could think about changing cosine x or cosine squared to like 1 minus sine squared x, right? But it's telling us to have our answer in tangent. So the way tangent is supposed to look like sine over cosine. But because both of them have squared, we're not going to cancel out. That just means that our answer would be tangent. But because they both have squared, it would be tangent squared. So that's our answer. And just so you know, the original things that I wrote up here, like sine is equal to 1 over cosine, or not cosine, cosecant. If there's a squared, you just gotta add squared on both of them. So like if sine, it would equal the same thing as this. So just in case you end up doing this in one of your equations, you just add the square if it has a square. Now here's the next one. We want it to be in secant. So 1 minus secant squared. The equation that involves secant is 1 plus tangent squared equals to secant squared. So if let's see, 1 minus secant, I need to get the secant to minus over here. I can subtract the tangent here, which is secant squared minus tangent squared, and then I can subtract the secant there. But it's probably simpler, so I'm just going to subtract the secant here, right? But then if I want to move the tangent to the other side, that means I'm subtracting 2, so that'd be a negative tangent. This right here is equivalent to negative tangent squared. So I'm going to rewrite that. Negative tangent of x, negative tangent squared. And for now, I'm going to keep the sine as a sine. If I want to divide these two, I'm going to change the tangent into sine over cosine. So it involves cosine because I know secant is the opposite of cosine. So I want either one of those to be in it so that I could get closer to the answer, basically. So if I change this one right here into here, it would be, so this is dividing, so I'm actually gonna create 2 fractions and multiply it, but make sure that the bottom fraction is the reciprocal. So you switch the denominator and the denominator. The negative tangent is equal to negative sine squared of x over cosine squared multiplied by this, but the reciprocal, so it's 1 over sine. So the reciprocal of this, you just add 1 to the denominator if you need it, because we need it as a fraction. And then I multiply the numerator, which is just the same thing, and then the denominator is both of those 2 multiplied together. Make sure it's a negative. And then if I look at that, I can cancel out the sign, both of the signs. So now it's just negative 1 over cosine squared x. But because we know 1 over cosine is equal to secant, which is the opposite, it's just secant, negative secant. But because we have the squared here, like I said last time, if there's a square, just add square for everything else. Answer is going to have a square in it, and that's our answer. So number 4, we wanted to end with secant only. So here we have cosecant and we have tangent here. So I know I can change cosecant into 1 over sine of x, and I can change tangent into sine over cosine. So then when we multiply these two, then we can get rid of the sine because it's the same top and bottom. Then all we have is 1 over cosine of x, which is equal to secant. So to know what you're switching to, which is probably the question you're asking, maybe, I don't know. No, it's just what can it switch to? But the tangent, though, it could switch to cotangent. But the thing is, if you're doing cotangent still has the two values of sine and cosine. So like you want to break it down even further, which is using cosine and sine. The cosecant can basically only do 1 over sine. Now moving on to number 5, we want sine of x. So that's a lot right here. So I'm going to change the secant into 1 over cosine of x multiplied with cotangent, which I could do as 1 over tangent, but I want to break it down even further. So basically the opposite of tangent. Tangent is sine over cosine, so the opposite, or switch the numerator and denominator. And then tangent squared, like I said last time, normal tangent is just sine over cosine, right? So because there's a square there, just add a square to everything else. Now if we multiply everything, okay, so let's look at what we can cross off. I can take these two out, and there's this sign, which has the power of 1 down here, and this sign to the power of 2, so I can take this out, and then this becomes a 1. So this would be sine over cosine squared of x. I can't cross off anything else unless I change one of them. So it looks like I can break down this denominator right here, cosine squared x. The equation that has that is this one, like we did earlier. So to get cosine squared, I isolate it, which is just subtracting the sine squared. So it's equal to that. So I just rewrite that. And that should be our answer. That includes only sine. So now number 6 is finding cosine. We have here cotangent. I don't want it 1 over tangent, so cosine over sine multiplied with cosine, so that's just cosine. But because I'm multiplying with a fraction, I like to add 1 over 1 so I know what I'm multiplying with. Divide that with, right here we have cosecant, which I can change that into 1 over sine. Now I'm going to multiply these two first, then multiply it with the reciprocal of this denominator. So if I multiply these two, it'd be cosine squared of x over sine, cosine squared x over sine, multiplied with the reciprocal, so put that at the top and that at the bottom. Then that would equal cosine squared x sine over sine of x. Then we can get rid of the sines, and then our answer is just cosine squared x. These next two questions, basically we are going to be looking at the graph, and we have our triangle on the graph with those values. The trig functions that we find out we need to use. We can see here all these. Okay, we're finding all of those, which is based on the sum and difference identities and double angle identities. So make sure you remember those. I guess you can look, but you can also just look at them while you are practicing too. But obviously practice while not looking at them too. So let's go ahead and get started with this one. Before I do this, and you probably should do it too, I like to draw out the triangle and put in the values, as in cosine and sine values. And those are the only two values that we need right now, because all of these formulas, they only use the cosine and sine values. So for this first circle, sine of A, that's our x, basically that's our theta. It's basically an A, I'm not sure what it's called, but that it's equal to, so sine is opposite over hypotenuse. We know the hypotenuse should be 5 because that is the radius. The hypotenuse is always 5, so that's at the bottom. So sine is O over H, right? But if we're dealing with these circle graphs, when we're looking at like a triangle on a circle, we're not really using O over H. It is still over H, but based on these coordinates and the radius, technically whatever we're doing is equal to y, because sine is y over the radius. Same thing goes with the cosine here. So the cosine of A is going to equal to whatever, but that's basically x over radius, which is the same thing as adjacent or hypotenuse. The y value for sine is based on this coordinate right here, so the y value is 3. Then the x value for cosine is 4, and then the radius is, so these are the two values here. With this triangle over here, which is b, sine it would be y, right? So the y is 12, and the hypotenuse, which is the radius, is 13. Then cosine is x over radius, which is 13. So those are our 4 values. Now using the formulas and those 4 values. So this first formula looks like the one that is equal to sine 2 theta. And basically it is this. So using that, we want to plug in the 2 values. Instead of the thetas, that would be our a. So to find that, it would be 2 times this. So we know that I'm actually going to erase the theta. I guess I have to rewrite the entire thing. Replace theta with the a. And if we use this, so first thing is sine of a. We know sine of 8 up here is equal to that, so 3 over 5. And then cosine of a, which is equal to this. That's 4 over 5. So when we multiply them all together, if I multiply these two first, I like to do that first, so that's 12 over 25. Then multiply these two, it would give me 24. So this is basically 2 over 1, so 24 over 25. And that's our answer for number 7. So for number 8, this is the formula we're using, which is a sum and difference identity. If I write down the formula is this. So because we have plus sign, we're going to be using a plus sign and not a minus. So if I write that, so sine of a, 3 over 5, cosine of b, which is 5 over 13, plus cosine of a, which is 4 over 5, and then sine of b, which is 12 over 13. Alright, and multiply these two and these two. This means 15 over 65 plus 48 over 65. If we add those two, that's easy because it has a common denominator, or the same denominator, so 63 over 65 should be your answer. So for number 9, it's the same type of equation, but cosine instead. So this is the equation. The thing about cosine though, it's the opposite symbol, so I like to write it like that. If we write it like this, it'd be the same symbol that we get, but for cosine, it's the opposite. So like if we have negative here, we're going to be using plus sign. Let me finish writing this. Alright, and now we can start filling it in. So cosine of a, 4 over 5, cosine of b, 5 over 13. The opposite, which is plus, sine over a, which is 3 over 5, and then sine over b, which is 12 over 13. Now if we do all of that, that's 20 over 65 plus 36 over 65. That gives me 56 over 65. And that's our answer. Now moving on to the next one. This circle right here is probably a bit confusing because look at that. That's like over 90 degrees. So it kind of defeats the rules of SOHCAHTOA. But because, like I said before, we're not going based off of like hypotenuse and adjacent and opposite. We're going based off the x and y values and the radius. So sine of a, cosine of a. Sine is y over the radius, so that's 3. And cosine is x over the radius. Same applies with this next one here. Square root of 7 over 4 and 3 over 4. So using that, we can find these 3. So cosine of 2a. So this equation right here has like 3 versions. You choose whatever you want to use, but I'm gonna use the cosine, the one that only has cosine, which looks like this. But you can use the other two. Just all you have to do is plug it in. Plug in cosine of a, That's our a value right there. But make sure that whatever you plug in, you have to square it, right? Because there's a square symbol there. So squaring that gives me 4/9. Negative times negative is positive. And if I multiply that by 2/1, that gives me 8/9 minus 1. But I want to change that. So it has a denominator of 9, so multiply by 9. And that gives me -1/9. So number 11 is the same thing as we did for number 8, except it's a negative. Hopefully you kind of remember the formula. So sine of A first, right? So that's this. Nope, it's this. Then we have cosine of B minus the same symbol. Then we got cosine of A, and then sine of B, which is square root of 7/4. Alright, so these values, they're kind of like, I don't know the word, but I would say disgusting. So you just multiply them though. This is a negative. This would be equivalent to just, you can't really do anything there, so it's just this, the same thing. But because it's two negatives, I will change it to a +12/, and so that right there is our answer. So the last one, you have this again. So I start with cosine of A, which is -2/3, and then we go with cosine of B, then the opposite symbol, so that's a negative, then sine of A, and then sine of B. So the cosine one is kind of easier to memorize because it goes A, B, and then A, B, so all cosines first and then sines first. But this one's like sine, cosine, sine. No, not even sine, it's cosine, then sine, cosine, sine. So yeah, that one's harder to memorize in my opinion. Anyways, back to this. Well, when we multiply them, it's -6/12 minus square root of, multiply the numbers on the inside, which gives me square root of 35/12. If we simplify that, that would give me -6 plus square root of 35/12. The reason why the 35 became positive is because I put the negative out here already. And so that right there is our answer. Alright, so this is the last part of 3.12 worksheet A. So these are multiple choice, so which of the following expression is equivalent to this? So the formula, or the equation equal to this one is cosine 2 theta, right? So it'd be one of the three, and because we have a 4 here, we have to multiply each of the terms by 4. So if we look at this first one, this one is completely wrong. It doesn't even have a square, or yeah, a square. All three that equal to this right here have a square, so automatically A is wrong. These all have a square. Look at this one though. This one's plus sign. I know the everything's negative, so basically everything has a square and everything has a negative. So now if we look at this, so they're both cosine here, so either subtract 1 goes in the front or subtract 1 goes in the after the cosine. You just have to memorize here. D would be the answer because this one right here, it should be sine instead, and plus you'd have to multiply by 4, which this one did not. The 4 right here, basically you have your equation written and then you multiply the numbers by 4, right? Because this one is 2 here. Like, look for this one, for example, it's 2 cosine squared x minus 1, right? So I multiplied 4 with both of these terms, and that gave me this. So D is the answer. So for this one, ooh, this one's pretty difficult. But if I get these two, if I multiply these two, so 2 of these, right? That would give me sine squared x. So it's 2 of those. And then also cosine squared. So this would simplify to 2 of that. So we have that there. But I know that this one right here is one of the formulas that can simplify to sine 2x, and then we have these two right here. Clearly none of them look like that, so I need to simplify even further. So if I look at, let's see, sine squared of x can give me, this can equal to 1 minus cosine of x. This one right here can also give me 1 minus sine of x. So either way, if you simplify this one or this one, it's gonna give me the same thing, which is, and I'm gonna write it over here, sine 2x plus 1. If I simplify this one right here, it's 1 minus sine, right? And if we get rid of the one that we simplified, so let's say we simplified sine of x, so get rid of that, and it's equal to this. These two cosines, they just cancel out, because look, this is a negative, this is a positive, so they just cancel out, and then that leaves me with 1 plus sine of 2x. And the same thing would apply with if we simplified cosine squared of x. So which answer choice looks like this one? It is D, so our answer is D. Now 15, I can simplify this. I'm going to do it over here. Simplify the top two. What does this one equal to if I do the formula? The Pythagorean identity equivalent form formula. Let's see here. Get this to be -1. And then minus the cosine. So there we have cosine squared x minus 1 is equal to negative sine of x. So my numerator is equal to negative sine squared x over cosine squared x, which that would just give me negative tangent squared of x, so that is C. Now number 16, we have 1 plus cotangent. Oh, I can already see that this one right here is gonna equal to cosecant squared and multiplied by sine. But I can see that the sine can be simplified even further, or changed into 1 over cosecant squared. If I bring this down to, so I'm basically just, it'll basically simplify to this, and then both of them just cancel out, and so if they cancel out, it equals to a 1, so that's A. For 17, we have this here, so this is the formula right here, which you can write that, so that'd be 2 sine x cosine x, but because we have that 3 there, we would multiply the 3 with the 2, which gives me 6, so 6 sine cosine, and that's equivalent to C, because 3 times 2, and then we're just multiplying this, not like cosine, because it's not like there's a parentheses there, then we have to multiply both of them. Oh well, first of all, this is only like basically one whole big term. Now, our last question, number 18. So we're not given the beginning of the formula, we're given like the result, basically. If I look, this is cosine, cosine, sine, sine, so it looks like we're using this formula, right? So I know that this value is A, and then B, A, and then B. So it would just be cosine A, opposite symbol B, right? So we have minus here, so that should be plus. So whatever A is 5 pi over 9 plus B, which is 3 pi over 9. Then we gotta add those two, which gives me 8 pi over 9. So it should just be cosine 8 pi over 9, which is B. So that was worksheet A of topic 3.13. So hopefully that helped. Thank you so much for watching.